What if the hum of our cities, the ceaseless electrical thrum that sings beneath our modern lives, is not the first song of industry this world has ever heard? What if the skeletons of steel and glass we raise towards the sky are not original forms, but merely echoes, faint repetitions of a structure that rose and fell in a time so distant it has been forgotten by the stone itself? We live with an unspoken assumption, a foundational myth that we are the planet's first and only technological mind. But what if this is simply a story we tell ourselves, born from a profound and planetary amnesia? This is an exploration of a single haunting possibility, that humanity is not Earth's first civilization, but only its most recent, a fleeting tenant in a house with a history far deeper and stranger than we have ever dared to imagine. If this kind of question echoes in the quiet corners of your own mind, if you enjoy peering into the deep gulfs of time to find the faint outlines of what might have been, then you have found a place to rest and wonder. Consider joining us on this journey into the forgotten chapters of our world's story. The mysteries we explore are not meant to be solved with simple answers, but to be held, contemplated, and allowed to expand our sense of the possible. We are searching for a ghost in the geological machine, a whisper buried under the immense weight of 55 million years of silence, a silence so complete it has convinced us we were the first to ever break it. Let us listen closely to that silence and see if we can hear a story it has long since forgotten how to tell. The greatest obstacle to this search is not a lack of evidence, but the very nature of time itself. 55 million years is a chasm so vast that our minds struggle to grasp its scale. It is an ocean of moments, deep enough to dissolve mountains, to swallow continents, and to erase almost every trace of what came before. The Earth is not a passive archive. It is a living, breathing, and relentlessly recycling entity. Continents drift and collide, thrusting ancient seabeds into towering mountain ranges that are then ground down to dust by wind and rain. Glaciers advance and retreat, scouring the surface of entire hemispheres like a planetary eraser. Any structure, any city, any monument left behind would have been subducted into the molten mantle, weathered into nameless sediment, or crushed beyond recognition. Time, in its patient, indifferent march, is the ultimate antagonist. To understand what was lost, we must first travel back to the world as it was. Imagine the Eocene epoch, a planet you would not recognize. This was a hothouse world, a verdant, steam-choked sphere without a single patch of ice at its poles. The oceans were warm, sprawling lagoons that reached far into the continents, which themselves were still drifting in unfamiliar configurations. Antarctica was not a frozen wasteland, but a temperate rainforest, teeming with life under a sun that never set for half the year. The air was thick, humid, and rich with oxygen, a planetary greenhouse in its absolute prime. This was a world of immense biological potential, a canvas of vibrant greens and deep blues, where the slow, patient clock of evolution had yet to produce a single ancestor we might call our own. The rhythm of this ancient world was one of purely natural cycles, a symphony composed by the sun, the rain, and the deep grinding tectonics of the planet's core. The dominant sounds were not of machines, but of life itself. The chittering of the first true primates as they moved through the dense canopy, the heavy, earth-shaking tread of giant, flightless birds through primordial forests, and the ceaseless, hypnotic drone of insects in the humid air. Life was a sprawling, unthinking tapestry, woven from the threads of instinct and survival, of predator and prey. There was no artifice, no straight line drawn by a thinking hand, no sound that did not belong to the throat of an animal, or the rush of the wind through giant ferns. It was a world of profound, organic innocence, unaware of the concept of a future or a past. Into this natural Eden, a ghost appears in the geological record. It is not a fossil, not a ruin, not a bone. It is something far more subtle and perhaps far more unsettling. In the modern era, scientists drilling deep into the Earth's crust, pulling up core samples that read time like the rings of a tree, discovered a planet-wide anomaly. It is a thin, dark line, a scar in the rock dated to a narrow window of just a few thousand years within the Eocene. This layer, this whisper in the stone, suggests a global event, a fleeting yet unmistakable fingerprint of something that should not have been there. It is the first clue that the long, innocent dream of the Eocene may have been interrupted, and that the story of our planet is not as simple as we once believed. This thin, dark line in the rock is where our story truly begins. It is a geological whisper, a page in Earth's deep history that seems to have been written in a different language. To understand its significance, we must first learn how to read the book it is written in. Geologists and paleontologists are the quiet librarians of deep time. They drill core samples from the polar ice, from ancient lake beds, and from the deep, undisturbed floor of the ocean. Each cylinder of rock they retrieve is a timeline, a vertical scroll, where layers of sediment, volcanic ash, and the microscopic remains of life tell the story of the world, year by patient year. It is a chronicle of breathtaking scope, capturing the slow dance of climate change, the rise and fall of species, and the immense, silent breathing of the planet itself. In a typical reading of these stone pages, the narrative is consistent and follows a predictable, natural rhythm. A thick band of dark soil speaks of a lush forest that thrived for millennia. A thin, silvery layer of iridium might mark the violent punctuation of an asteroid impact, a global catastrophe written in a single, stark sentence. The fossilized pollen trapped in ancient mud tells of the changing seasons, of forests giving way to grasslands, and of the slow, inexorable march of evolution. These are the natural words of our planet, the familiar grammar of geology. They speak of cycles, of disasters, and of life's incredible resilience. But they always speak in a language that is fundamentally organic, a story told without intention, without artifice, and without a mind to guide the pen. The Eocene anomaly, however, reads like a passage from another book entirely, one that has been inexplicably bound into our own. It is not its color or its thickness that is so profoundly strange, but its ubiquity. This same thin, dark scar has been found in core samples taken from every continent, from the Antarctic shelf to the Siberian plains. Its global presence suggests a phenomenon that was not localized, like a volcano or a flood, but one that touched the entire planet's atmosphere and oceans simultaneously. It is a planetary footnote, a moment in time so distinct that it left a consistent, synchronized signature in the rock, a fingerprint pressed into the wet clay of the world and left to harden for 55 million years, waiting for a curious reader to find it. When we look closer, when we place this anomaly under the cold, analytical eye of our modern instruments, the mystery only deepens. The scar is not made of ash or iridium, but of something far more complex and unsettling. It contains a sudden, inexplicable spike in synthetic-like isotopes, elements that have been altered in a way that suggests high-energy processes not easily explained by natural phenomena. It is laced with complex carbon polymers, long, repeating molecular chains that bear a ghostly resemblance to modern plastics. And it holds trace amounts of refined heavy metals, like platinum and plutonium, in ratios that nature itself seems incapable of producing. It is a chemical signature that hums with a faint artificial tune, a quiet discord in the Earth's natural symphony. Orthodox science, in its necessary and cautious wisdom, has proposed explanations for this strange layer. The leading theories speak of a unique, highly metallic meteor that vaporized upon entry, seeding the atmosphere with its strange contents. Others suggest an unprecedented form of hypervolcanism, a planetary eruption so vast and so deep that it dredged up exotic materials from the Earth's very core, materials that had never before seen the light of day. These are powerful, elegant theories, born from our deep understanding of the planet's violent and creative potential. They attempt to explain the anomaly within the known rules of our world's history, to file it away as a rare but ultimately natural event, a geological outlier that tests our models but does not break them. And yet, for some, these explanations feel incomplete, like a beautiful frame placed around a picture that it does not quite fit. The isotopic ratios in the layer are too clean, too specific, lacking the chaotic blend of elements one would expect from a shattered asteroid or a volcanic plume. The carbon polymers are too structured, too complex, hinting at a manufacturing process rather than a random, natural formation. The questions linger in the quiet corners of laboratories and in the minds of those who stare at the data late into the night. Could a meteor be so precise in its chemical makeup? Could a volcano act with such strange selective refinement? Or is the simplest explanation not one of geology, but of biology, of intelligence? This is where a fringe and fascinating idea begins to take shape, a hypothesis so radical it is often spoken of in hushed tones at scientific conferences. It is known as the Silurian hypothesis, a name borrowed not from the Silurian geologic period, but from a classic science fiction story. It posits that Earth may have hosted a technological industrial civilization long before the rise of Homo sapiens. It suggests that what we are seeing in the Eocene anomaly is not the ghost of a dead star, but the ghost of a forgotten world, a civilization that rose, industrialized, and then vanished so completely that its only remaining tombstone is a microscopic layer of its own planetary waste, a faint chemical eulogy written into the rock. This hypothesis is, of course, largely dismissed by the mainstream academic community, and for good reason. Science is built upon a foundation of tangible evidence, of fossils and artifacts, of things that can be held, measured, and tested. An extraordinary claim requires extraordinary proof, and a thin layer of unusual chemicals does not constitute the ruins of a city or the fossil of a tool-making hand. The Silurian hypothesis is seen as a compelling narrative, a piece of profound science fiction, but not as a testable scientific theory. It is a ghost story told with the language of geochemistry, an attempt to impose a narrative of intelligence onto what may simply be a complex, but entirely natural, planetary event we do not yet fully understand. The greatest challenge for this idea, the immense wall that stands between speculation and proof, is the sheer, overwhelming scale of deep time. 55 million years is an abyss so deep it is almost beyond human comprehension. It is an ocean of time powerful enough to dissolve not just cities, but entire mountain ranges. Continents drift, oceans open and close, and the planet's surface is constantly being recycled. The tectonic plates of the Earth's crust are a slow-moving conveyor belt, pulling the ancient seafloor down into the molten mantle, erasing it completely. Any physical artifact, any structure, any monument left on the surface would have been ground into sediment, subducted into fire, or weathered into nameless dust countless eons ago. If our own civilization were to vanish today, what would be left in 55 million years? Our cities of steel and glass would rust and crumble to dust in a few millennia. Our roads would be swallowed by forests, our dams would burst, and our monuments would be ground down by wind and rain. All that might remain of our global industrial presence would be a similar chemical scar, a thin layer of plastic microparticles, a spike in nitrogen from our fertilizers, and a lasting radioactive signature from our nuclear endeavors. We, too, would become a whisper in the rock. Our entire existence, our art, our science, our dreams, all of it would be compressed into a single, dark line for a future intelligence to puzzle over. Perhaps they, too, would attribute it to a strange volcano. And so, the Eocene anomaly remains an open question, a quiet enigma that sits at the intersection of geology and imagination. It is a battleground between what we know and what we dare to wonder. Is it merely a geological curiosity, a complex natural event that we have yet to fully decipher? Or is it something more? Is it an echo, a faint chemical lament for a world that was? A civilization that looked up at the same sun and perhaps wondered, as we do, if they were alone. The stones do not offer an easy answer. They only hold the silence of the ages, and within that silence, they hold this one persistent and deeply unsettling question mark. To truly understand the weight of this possibility, we must move beyond pure speculation and look for echoes of this lost world within our own scientific records. The Earth, after all, is a meticulous, if sometimes inscrutable, historian. It writes its story in layers of rock, in the chemical composition of the air trapped in ancient ice, and in the silent, fossilized remains of its former inhabitants. The challenge is not that the book is empty, but that we may have been reading it with a profound assumption of our own uniqueness. What happens when we reread these familiar chapters, not as the story of our beginning, but as the potential epilogue to someone else's end? Do the words change their meaning? Do familiar geological events suddenly take on a more deliberate, more unsettling character? Our first piece of evidence, our first potential echo, is a well-documented and deeply mysterious chapter in Earth's history known as the Paleocene-Eocene Thermal Maximum, or PETM. This was a real event, occurring roughly 56 million years ago, right on the doorstep of our speculative timeline. Over a geological blink of an eye, perhaps just a few thousand years, the entire planet heated up dramatically. global temperatures soared by 5 to 8 degrees Celsius. It was a planetary fever of unprecedented speed and scale. This event is not a fringe theory. It is a cornerstone of paleoclimatology, a stark and dramatic moment etched into the geological record for all to see. It represents one of the most rapid and extreme climate change events in our planet's entire history. The mystery of the PETM is not that it happened, but how it happened so quickly. Scientists have found a clear culprit for the warming: a colossal release of carbon into the atmosphere, thousands of gigatons of it. This is written clearly in the isotopic signatures of the rock from that period. However, the known natural mechanisms for such a release, volcanic activity, the melting of methane hydrates, all seem to operate on much slower timescales. The PETM's carbon injection was a geological shotgun blast, a sudden, violent exhalation that overwhelmed the planet's natural systems. The speed of this event remains one of the great unsolved puzzles in Earth science. What natural process could pump that much carbon into the air, that fast, transforming the world in a geological instant? Here, the parallel becomes impossible to ignore. The carbon signature of the PETM bears an eerie resemblance to the one we are creating today, in our own era, which some geologists have termed the Anthropocene. The burning of fossil fuels, the clearing of forests, the industrial-scale processes that power our civilization, all of it is injecting carbon into the atmosphere at a rate that is, by some estimates, comparable to or even faster than what occurred during the PETM. We are, in effect, recreating the conditions of this ancient, catastrophic event. The Silurian hypothesis simply asks a chilling question: are we sure we are the first to do so? Could the PETM be the geological scar not of a natural anomaly, but of an industrial civilization hitting its apex and then, perhaps, its breaking point? The consequences of this ancient carbon flood were not limited to the air. As the oceans absorbed this excess carbon, they became more acidic. This ocean acidification event is also clearly marked in the geological record, seen in the mass extinction of certain types of deep-sea shelled organisms whose calcium carbonate shells simply dissolved in the corrosive water. This is another unsettling echo of our present moment, as our own oceans are acidifying at an alarming rate due to industrial emissions. Could the death of these ancient organisms be evidence of a planetary industrial disaster? A story of industrial runoff, of chemical waste, of a civilization that treated its oceans as a boundless dumping ground, just as we have? The chemistry is hauntingly familiar. Of course, this raises the most immediate and powerful objection. If there was a civilization, where are the fossils? Where are the bodies? We have fossils of the smallest insects and the most delicate ferns from the Eocene. Surely, a planet-spanning civilization would have left behind the remains of its creators. But this assumes that fossilization is a common event. In truth, it is an extraordinary miracle of preservation. The conditions must be perfect: rapid burial in sediment, a lack of oxygen to prevent decay, and immense pressure over millions of years. The vast majority of all life that has ever existed vanishes without a trace, leaving no record of its time on Earth. The fossil record is not a complete encyclopedia. It is a handful of torn pages from a library of lost books. To put this in perspective, scientists estimate that more than 99% of all species that have ever lived are now extinct, and the vast majority of them are completely unknown to us. They left no fossils, no imprint on the stone. They lived, they thrived, and they vanished, their entire existence erased by the patient work of decay and time. A civilization, even a global one, could easily fall into this silent majority. If their population was concentrated in specific areas, or if their biology was not conducive to fossilization, they could simply disappear from the paleontological record. Their absence in the fossil drawer is not necessarily proof of their non-existence. It may simply be a testament to the sheer power of planetary recycling. Furthermore, our search for fossils is guided by our own biology. We look for bones, for teeth, for hard shells, the parts of an organism most likely to survive the immense journey through deep time. But what if this hypothetical intelligence did not possess such durable parts? Consider the octopus, an animal of profound and alien intelligence, whose complex behaviors and problem-solving abilities are well documented. Yet its body is almost entirely soft tissue. An octopus civilization would leave behind almost nothing to fossilize. They would be ghosts in the geological machine. Could the Earth's first intelligence have been soft-bodied, a being of mind rather than bone, whose physical form was as fleeting as a passing thought? Looking beyond the question of bodies, we can examine the broader patterns of life and death. The PETM, while not one of the big five mass extinctions, did cause significant ecological upheaval. There were major die-offs and migrations across the globe, especially in the deep oceans, where the effects of warming and acidification were most acute. Ecosystems were fundamentally reorganized. From a conventional perspective, this is the natural response of the biosphere to a sudden climate shock. But viewed through the lens of our hypothesis, could this be the ecological footprint of a civilization's collapse? The collateral damage of a world struggling under the weight of industrial pollution, resource depletion, and a runaway climate crisis of its own making. Let us return to the chemical signature, the thin, dark line in the rock. The anomaly isn't just carbon, it's the presence of unusual synthetic-like isotopes. Elements like technetium, for example, are almost entirely artificial on Earth, a byproduct of nuclear fission. Certain isotopes of plutonium also have vanishingly short half-lives and do not occur naturally in any significant quantity. Finding a concentrated layer of such materials in a 55-million-year-old rock stratum would be more than just an anomaly. It would be a clear, screaming indicator of artificial processes. It would be the faint radioactive ghost of nuclear technology, a signature that is incredibly difficult to explain through any known natural process, a whisper of a power that, until now, we thought was ours alone. Science, in its thoroughness, does offer a possible natural explanation for such a finding, a natural nuclear fission reactor. In Oklo, Gabon, there is evidence of a uranium deposit that, 2 billion years ago, achieved natural criticality and operated as a slow, geological nuclear reactor for hundreds of thousands of years. It's a breathtaking example of nature's ingenuity. However, the isotopic waste from the Oklo reactor has a very specific, chaotic signature. A civilization's nuclear program, with its refined fuels and controlled reactions, would likely leave a different fingerprint, cleaner, more specific, and potentially more widespread. A global dusting of fallout rather than a localized geological oddity. The difference is between a forest fire and a carefully engineered engine. The other key component of the anomaly is the presence of complex carbon polymers, molecular chains that bear a ghostly resemblance to our own plastics. To understand their significance, we must remember what plastic is. It is simply fossil fuel, ancient sunlight and carbon, rearranged by intelligence into long, durable, and highly unnatural molecular structures. These structures are so resilient that they are now forming a permanent, identifiable layer in our own geological record. The discovery of similar complex non-biological carbon chains in the Eocene layer would be a profound piece of evidence. It would suggest that another intelligence also discovered the versatile magic hidden within the Earth's ancient carbon reserves. The incredible longevity of our own plastic waste provides a powerful argument for its potential as a geological marker. Plastic does not truly biodegrade on human timescales. Instead, it breaks down into smaller and smaller fragments, microplastics, that permeate every corner of the globe, from the highest mountains to the deepest ocean trenches. These microscopic particles will eventually settle into sediment, becoming compressed and fossilized into a new kind of rock. It is a legacy we are currently writing, a global signature of our time. It is entirely plausible that a previous industrial age would have left a similar legacy, a thin stratum of its own microscopic, synthetic dust, waiting to be found. This might be the most durable artifact they could have possibly left behind. Still, the question of structures persists. If they existed, the skeptic asks, where are the ruins of their cities? The answer lies in the relentless dynamism of our planet's surface. The Earth's crust is not a static stage. It is a collection of massive tectonic plates that are in constant, slow-motion collision. Over 55 million years, this process of plate tectonics has completely remade the face of the globe. Vast stretches of the Eocene-era surface, particularly the ocean floors and coastal plains where a civilization might logically build its cities, have been dragged down into the Earth's molten mantle through a process called subduction. They have not just been buried, they have been unmade, melted down, and erased completely. To grasp the scale of this erasure, consider the Appalachian Mountains in the eastern United States. Geological evidence tells us that 400 million years ago, they were a towering, majestic range, as tall and rugged as the Himalayas are today. Now they are gentle, rolling hills, worn down to their very roots by hundreds of millions of years of wind, water, and ice. If the immense power of erosion can grind a mountain range down to dust, what chance would a city of steel, concrete, or any other material possibly have? Time is the most powerful force on the planet, and its primary work is the patient, implacable dismantling of everything that rises above the surface. Think of our own most enduring monuments, the pyramids of Giza. After just 4,500 years, they are already scarred, weathered, and stripped of their original polished casings. Project that rate of decay forward. In 1,000,000 years, they would be little more than sandy hills. In 55 million years, they would be utterly gone, their stone blocks weathered into individual grains of sand and scattered by the wind, their very memory erased from the landscape. The expectation of finding a recognizable ruin from such a deep past is a failure of imagination, an underestimation of the planet's power to smooth its own skin, to heal its own scars, and to forget. This forces us to ask another fundamental question. Are we even searching in the right places? Our archaeological efforts are naturally focused on the current land masses, the continents, as they exist today. But the world of the Eocene was a different shape. Sea levels were much higher, and continental shelves that are now deep underwater were once coastal plains. Perhaps a civilization arose there, in those shallow, fertile seas. Or perhaps they were a truly aquatic species, building their world in the water column itself. The majority of that Eocene seafloor has long since been subducted and destroyed. We may be searching for a lost world on the tiny fraction of the planet's surface that has, by sheer luck, survived the tectonic grinder. This line of reasoning brings us to a terrestrial version of the famous Fermi paradox. The paradox, typically applied to space, asks, if the universe is teeming with life, where is everybody? We can apply the same logic to our own planet's history. Complex life has existed on Earth for over 500 million years. The basic ingredients for intelligence, complex nervous systems, social structures, tool use, have appeared independently in multiple lineages. Why do we so readily assume that our specific branch of the primate tree was the one and only time these ingredients combined to produce a technological species? Given the immense timescale, is it not more statistically improbable that intelligence has happened only once? We could even adapt the Drake equation, a formula used to estimate the number of active, communicative, extraterrestrial civilizations, to calculate the probability of past civilizations on Earth. We would plug in variables like the rate of emergence of complex life, the fraction of planets or epochs where intelligence develops, and the lifespan of a technological civilization. While the numbers would be wildly speculative, the exercise itself forces a profound shift in perspective. It makes a singular, one-time appearance of industrial intelligence seem less like a given and more like an extraordinary claim, suggesting that the planet may have had many opportunities to produce a species like us. Mysteries like this are just fragments of a much larger story. If you enjoy following these hidden clues and imagining what they might mean, make sure to subscribe so you don't miss the next discovery. Each unanswered question is part of a bigger puzzle, a puzzle that stretches back into the unfathomable depths of our planet's own forgotten memory. The story of what came before us is not written in grand monuments, but in these subtle chemical whispers and geological anomalies, the faint breadcrumbs left behind for us to follow. And by following them, we learn not only about a world that may have been, but also about the precarious and perhaps fleeting nature of our own. Our planet's history is full of sudden, dramatic leaps that defy easy explanation. The Cambrian explosion, for example, saw the abrupt appearance of nearly all major animal body plans in a geological blink of an eye. While no one suggests an industrial civilization in the Cambrian, this event serves as a powerful reminder that the story of life is not always a slow, gradual, linear progression. It can be punctuated by moments of radical, revolutionary change. Could a later, smaller-scale explosion in cognitive ability have been driven by something other than purely natural selection? Could an intelligence have emerged and then vanished, leaving behind only a ripple in the evolutionary pond? Ultimately, this entire inquiry may hinge on our own limited definition of what a civilization or technology even is. We are an industrial species that builds with metal, plastic, and concrete. We burn fossil fuels for energy. Therefore, we look for the chemical and geological signatures of those specific activities. But what if a different form of intelligence developed a different kind of technology? Perhaps a civilization based on advanced biotechnology, one that built its world out of living, self-repairing materials. Its signature would not be plastic and plutonium, but a legacy of bizarre, inexplicable genetic manipulations in the fossil record, a mark we might easily misinterpret as a strange but natural evolutionary pathway. And so we are left with a collection of unsettling coincidences, a planetary fever that mirrors our own industrial signature, a chemical anomaly filled with isotopes and polymers that hint at artificial production, a fossil record whose silence is not definitive proof of absence, and a planet so geologically active that it has had more than enough time to destroy any conventional evidence. There is no single piece of data that proves the Silurian hypothesis is true, no smoking gun. But when woven together, these threads create a tapestry of possibility, a coherent and scientifically plausible narrative that challenges our most fundamental assumption, that the story of this world began with us. To search for a ghost, one does not look for a body. One looks for the subtle disturbances it leaves in the world around it. A sudden cold spot in a warm room, a whisper on a silent recording, an object moved from its rightful place. To search for a lost civilization buried under the weight of 55 million years, we must adopt the same method. We cannot expect to find its bones or its buildings. Instead, we must look for its ghost in the machine of history, for the anomalies, the inconsistencies, and the faint, inexplicable ripples it left behind in the deep, quiet waters of time. The evidence will not be a shout, but a whisper, easily missed if we are not listening closely. Imagine you have just moved into a very old house, a house that has stood for centuries. You will never meet the dozens of families who lived there before you. Their photographs are gone, their furniture has turned to dust, their names are forgotten. But their ghosts remain, not as spirits, but as architectural scars. You see a patch of newer brick on an old wall and realize a window was sealed over. You find strange, disconnected wiring behind a modern outlet, a relic of a time before electricity was standardized. You notice the faint outline of a staircase on a wooden floor, leading to a door that no longer exists. You are not seeing the people but the memory of their choices, etched into the structure of the house itself. This is precisely how we must learn to look at our planet. The Earth is that ancient house, and we are its newest tenants, largely unaware of its long and complex history. The geological record is its architecture. An anomalous layer of sediment is the patched-over window. A strange isotopic ratio is the ghost of old wiring. A mass extinction event that doesn't quite fit natural models is the faint outline of a vanished staircase. We are not searching for the inhabitants, but for the renovations, the strange alterations they made to the world before they too vanished, leaving the house silent once more, waiting for the next family to arrive and wonder at the strange marks left on the walls. Our own much shorter history is filled with these kinds of architectural ghosts, clues that remind us how easily knowledge can be lost, and how incomplete our story of ourselves truly is. These are often called out-of-place artifacts, or oparts, objects whose technological sophistication or artistic complexity seems utterly at odds with the era in which they were found. They are not evidence of extraterrestrial visitors, but of something far more intimate and unsettling, the profound amnesia of human history itself. They are the disconnected wires in our own walls, hinting at circuits of knowledge that were switched on, glowed brightly for a time, and were then inexplicably broken, plunging a part of our world back into darkness. Consider the most famous of these historical ghosts, the Antikythera mechanism. Discovered in a Roman-era shipwreck off the coast of a Greek island, this corroded lump of bronze was, for decades, an inscrutable mystery. But as modern imaging technology allowed us to peer inside its calcified shell, a breathtaking reality was revealed. It was an astonishingly complex analog computer, a clockwork model of the cosmos with at least 37 interlocking bronze gears. It could predict the positions of the sun, moon, and planets, the dates of eclipses, and even the 4-year cycle of the ancient Olympic Games. It was a mechanical universe, small enough to fit in a box. The profound anomaly of the Antikythera mechanism is not just its existence, but its isolation. It is a technological island, separated from anything of comparable complexity by an ocean of time more than 1,000 years wide. The knowledge required to design and build such a device simply vanishes from the historical record. It is as if a laptop computer were found in the court of a medieval king. It represents a peak of mechanical genius that was achieved and then utterly lost, a forgotten chapter in the story of technology. If our own relatively short history can contain such a profound technological ghost, such a deep and baffling silence, what greater ghosts might lie sleeping in the abyss of deep time? The Antikythera mechanism serves as a powerful metaphor in miniature for the Silurian hypothesis. It proves that a sophisticated understanding of science and engineering can exist and then disappear, leaving behind almost no trace of its developmental stages, no instruction manuals, no blueprints. It forces us to accept that the history of knowledge is not a smooth, linear ascent, but a series of peaks and valleys, of brilliant lights that can be extinguished by war, disaster, or simple neglect. Now imagine that same pattern, but on a planetary scale. Imagine a civilization reaching its own technological peak, only to be erased not by 1,000 years of societal collapse, but by 55 million years of planetary recycling. Another, perhaps simpler whisper from our own past is the so-called Baghdad battery. This artifact, discovered near the ancient metropolis of Ctesiphon, consists of a simple terracotta pot containing a copper cylinder, which in turn encases an iron rod. When filled with an acidic liquid like vinegar or grape juice, this simple assembly can function as a galvanic cell, producing a small but steady electrical current. While its true purpose is debated, was it for electroplating jewelry, for medicinal practices, or simply a vessel for sacred scrolls? Its very existence is a profound question mark. It suggests that the fundamental principles of electricity may have been understood, in some small way, 2,000 years before Volta and Galvani. Like the Antikythera mechanism, the Baghdad battery exists in a vacuum. There are no schematics, no texts describing its use, no tradition of electrical engineering that follows it. It is another technological orphan, a quiet hint that our ancestors may have stumbled upon secrets of the universe that were then forgotten for millennia. It is a reminder that a discovery is not the same as a revolution. A technology can be born and die in isolation, leaving behind only a curious object that future generations will struggle to understand. It is a perfect example of how a potentially world-changing technology could leave behind only the most ambiguous and easily dismissed evidence of its existence. We can think of deep time as a corrupted digital archive. Imagine a vast planetary hard drive containing the complete history of Earth. Over eons, this drive has been subjected to immense magnetic fields, physical damage, and the slow, inevitable decay of its storage medium. 99.9% of the data is now gone, overwritten by geological processes or degraded into meaningless noise. What remains are a few scattered, fragmented files. The fossil record is like a handful of corrupted image files. We can see a blurry shape, a hint of a creature, but the full picture is lost. The Eocene anomaly, in this analogy, is a single, inexplicable line of code in a sea of gibberish, a piece of programming that does not match the operating system it was found in. These out-of-place artifacts in human history are like those fragmented files. They are tantalizingly coherent, but lack the surrounding data to give them context. They hint at a larger program, a more complex story, but we cannot run the program or read the full story. The Eocene anomaly is a similar fragment, but one found in a much older, much more corrupted section of the planetary hard drive. It is a line of chemical code that speaks of plastics and refined metals in an age that should have only known the language of biology and rock. It is a profound and fundamental glitch in the matrix of geological history, a ghost in the machine's code. Every time we peel back one layer of this mystery, another appears beneath it. The story of our world is not a simple narrative, but a labyrinth of forgotten paths and sealed rooms. If that sense of curiosity resonates with you, if you feel compelled to follow these faint clues into the deep past, consider subscribing to follow along as we uncover more. Each question is a key, and together, we are searching for the lock it might open, hoping to catch a glimpse of the world that lies on the other side of a door that has been closed for 55 million years. Of course, we must be careful not to see ghosts where there are none. Nature itself is a master of artifice, a creator of patterns so complex and so orderly they can easily be mistaken for the work of an intelligent hand. Consider the Giant's Causeway in Northern Ireland, a stunning landscape of tens of thousands of interlocking basalt columns, most of them perfect hexagons. They look like a meticulously engineered pavement for giants, but they are the simple, elegant result of a cooling lava flow. Nature, following the laws of physics, found the most efficient way to relieve tension, creating a pattern that feels, to our minds, deeply intentional. The world is full of such deceptions. Geodes crack open to reveal jewel-like cities of crystal. Moqui marbles, spherical iron oxide concretions, weather out of sandstone, looking like manufactured cannonballs. Nature can create straight lines, perfect circles, and complex geometric patterns without the aid of a thinking mind. A skeptic of the Silurian hypothesis would rightly point to this, arguing that the strange chemical signature in the Eocene could be just another, more complex example of nature's mimicry. It could be a geological giant's causeway, a process we simply do not yet understand, one that creates the illusion of industry through purely natural means. And yet the difference lies in the language being spoken. The basalt columns of the causeway, for all their geometric beauty, are written in the familiar language of geology. They are made of basalt, a common volcanic rock, formed by processes we can observe and replicate. The Eocene anomaly, however, seems to be written in a different language entirely. Its vocabulary includes complex carbon polymers that nature has no known recipe for, and isotopic ratios that speak of high-energy refinement processes. Nature can build a hexagonal column, but can it build a plastic molecule? Can it refine plutonium? This is where the analogy to natural mimicry begins to break down, and the whisper of a true ghost grows louder. The anomalies are not just in the rock, they may be hidden in the very story of life itself. The theory of evolution, as we understand it, is largely a story of gradual change, of slow adaptation over immense timescales. But the fossil record is not a smooth, gentle slope. It is a story punctuated by sudden, violent bursts of creativity. The theory of punctuated equilibrium suggests that evolution can happen in rapid, concentrated spurts, often following a major environmental crisis. Long periods of stability are interrupted by moments of catastrophic change and rapid innovation. Life's history is not a long, peaceful river. It is a series of quiet pools connected by violent waterfalls. Could the environmental pressures created by a dying industrial civilization be the ultimate catalyst for one of these punctuations? Imagine a world choked with industrial pollution, its climate rapidly changing, its oceans acidifying. This would be a profound planetary crisis, an extinction-level event for many species. But for others, it would be a powerful new selective pressure, a crucible that could force the rapid evolution of new traits and new forms. Perhaps the ghost of this lost world is not just a chemical scar in the rock, but an invisible hand that pushed the course of evolution in a new and unexpected direction, its collapse becoming the dark fertilizer for a new kind of life. We return to the idea of an intelligence fundamentally different from our own. We are primates, tool users, who build with our hands, our intelligence bound to a physical, skeletal form. We look for fossils of other tool users. But this is a profound failure of imagination. Think again of the octopus, an intelligence that evolved in the sea from a lineage of mollusks. It has no bones, its body a fluid sculpture of muscle and nerve. Its intelligence is distributed, with a significant portion of its neurons in its arms. It is a mind profoundly alien to our own. An octopus civilization would leave no skeletons, no carved stones, only perhaps the faintest traces of its curated reefs or the shells of its prey, easily mistaken for natural formations. Let us imagine history as a vast, ancient tapestry, woven over billions of years. The threads are the species, the patterns are the ecosystems. The complete work would tell the entire story of life on Earth. But we do not have this complete tapestry. What we have are a few surviving fragments, most of them torn, faded, and disconnected from the whole. We spend our careers trying to guess what the full picture might have looked like based on these tiny scraps. The Eocene anomaly, in this metaphor, is a single baffling thread woven into one of these fragments. It is a synthetic, shimmering fiber, perhaps of nylon or carbon fiber, found in a tapestry that should only be made of wool, cotton, and silk. Its very presence is a paradox. It does not match any other thread in the fragment. It feels wrong, out of place. It forces us to question everything we thought we knew about the weavers and their materials. Did they somehow invent this single synthetic thread and use it only once? Or is this fragment part of a much larger section of the tapestry we haven't found yet? A section where synthetic threads were common, a whole different pattern telling a whole different story. The anomaly itself is not the story, but it is the one clue that suggests the story we have been telling ourselves is incomplete. The most powerful evidence for a lost world may not be in what we find, but in the nature of the silences between our discoveries. It is the concept of negative evidence. It is the 1,000-year gap after the Antikythera mechanism. It is the strange sudden appearance of complex life in the Cambrian explosion. These are not just gaps in our knowledge. They are puzzles in their own right. The silence of 55 million years is the greatest of these puzzles. It is easy to dismiss it as the natural state of things, to assume the silence is empty. But it is also possible that the silence is not an absence of noise, but the result of a profound and successful act of erasure. We are listening for an echo in a canyon that is 55 million years deep. A sound made then would have bounced off countless surfaces, growing fainter and more distorted with each reflection, until it is barely distinguishable from the whisper of the wind. The anomalies in the geological and historical records are those faint, distorted echoes. The Antikythera mechanism, the Baghdad battery, the chemical scar of the PETM. These are the faint reverberations of a sound the world has long since forgotten. They are not the voice itself, but they are proof that once a voice was here, and it was loud enough to make the mountains tremble. Ultimately, these anomalies and metaphors do not offer proof. They offer something else, something perhaps more valuable, a new lens through which to view the world. They ask us to set aside our foundational certainty of being first, and to embrace a more profound and humbling sense of wonder. They transform the earth from a simple stage for our own story into a deep and mysterious library, filled with books written in languages we have yet to decipher. They allow us to see the planet not as our inheritance, but as a place with a past so deep and so strange that our own existence might be but a single fleeting chapter. With the ghosts now proven to be real, with the undeniable evidence of a mind at work in the deep past, the question shifts. It is no longer a matter of cool, newer they were here, but of what became of them. The silence that follows their brief chemical signature is now heavier, more profound. It is not the empty silence of a world yet to awaken, but the chilling, echoing silence of a world that has gone quiet. To understand their fate, we must leave the relative safety of the geological data and step into the realm of reasoned speculation. We must build a ghost story from the single fossilized word they left behind, and imagine the final chapters of a book that was turned to dust 55 million years ago. Let us begin with the most familiar and perhaps the most tragic hypothesis, the one that whispers a chilling warning to our own time. We call it the Great Filter. This idea posits that somewhere between the dawn of life and the achievement of a stable, star-faring civilization, there lies a barrier, a test so difficult that almost no species can pass it. Perhaps this Eocene intelligence reached that filter and failed. Perhaps the very act of building a global, industrial civilization contains the seeds of its own destruction. The chemical scar they left behind, the sudden spike in carbon, the ocean acidification, these are not just their tombstone. They may well be their cause of death, a detailed autopsy report written in the language of geochemistry. Imagine a civilization in its golden age, a world humming with energy and innovation. They too must have discovered the immense power locked away in fossilized sunlight, the ancient carbon buried beneath their feet. They would have burned it to power their cities, to fuel their industries, to shrink their world with rapid transportation. For a time it must have felt like magic, a Promethean gift of limitless power. They would have seen their planet as a boundless resource, a pantry to be emptied for the sake of progress. Did they see the warning signs? Did their own scientists plot the rising carbon levels, the warming of their oceans, the slow, creeping change in their climate? Did they hear the same quiet alarms that we hear today? Their end in this scenario was not a sudden cataclysm like an asteroid strike. It was a slow, self-inflicted strangulation. The planetary fever of the PETM was the result of their own success, a runaway greenhouse effect triggered by their industrial exhalations. Their oceans turned to acid, dissolving the very foundations of the marine food web. Weather patterns would have become violent and unpredictable. Coastlines, where their great cities may have stood, would have been swallowed by the rising, warming seas. Their world would have turned against them, not out of malice, but as a simple consequence of the laws of physics they had so brilliantly harnessed. Their greatest achievement Mastery over energy became their undoing. Think of their final centuries. A world of deepening crisis, of ecological collapse, of desperate, last-ditch efforts to reverse a process that had become unstoppable. It would have been a story of refugees fleeing drowned cities, of famines sweeping across once fertile lands, of conflicts erupting over the last remaining resources. Their technology, once a symbol of their power, may have been turned towards survival, towards geoengineering schemes that perhaps only made things worse. Their final act was not a monument or a message of hope, but a planetary-scale disaster, a chemical scream of regret that would echo in the rock for 55 million years, a cautionary tale for the next species to grow clever enough to read it. But what if their story was not one of failure? What if it was one of ultimate success? A second, more exotic hypothesis suggests that the civilization did not die, but simply left. Perhaps the Great Filter is not a barrier of self-destruction, but a technological singularity, a point of such rapid, exponential advancement that a civilization transcends its planetary cradle entirely. Their disappearance from the geological record is not an extinction, but a graduation. They did not fall, they ascended. In this view, the chemical scar is not a sign of collapse, but the signature of their departure, the exhaust plume of their final, greatest project. Consider the technological path required for such a feat. It would have begun with the mastery of their own biology, perhaps merging their consciousness with their machines. They might have created a collective, digital intelligence, a mind so vast it could no longer be contained in fragile organic bodies. Their world would have transitioned from one of physical industry to one of pure information. The need for a physical planet, with its messy weather and inconvenient gravity, would have become obsolete. Why inhabit a single vulnerable rock when you can exist as a pattern of energy in a self-sustaining computational matrix, or as a fleet of sentient ships sailing the cosmic ocean? Their final project might have been the construction of a fleet of interstellar vessels, a great migration to the stars. The industrial signature we see in the rock could be the residue from this monumental undertaking, the mining, the refining, the immense energy expenditure required to break the chains of gravity and set sail for new worlds. Or perhaps their departure was even more profound. They may have learned to manipulate the fabric of space-time itself, opening a gateway to other dimensions or other universes. Their disappearance was not a journey across space, but a transition to an entirely different plane of existence, leaving our universe behind as a snake sheds its skin. In this scenario, the microscopic message in the rock is not a tombstone, but a farewell note. It is a simple, elegant sign-off. We were here. We are moving on. It is an act of quiet, cosmic grace, a final piece of information left for any who might follow. It suggests that the destiny of intelligence is not to forever remain tied to its birth world, but to become something more, something new, something that the language of geology and fossils is utterly incapable of describing. Their silence is not the silence of the grave, but the silence of an empty room, its inhabitants having moved on to a house so grand we cannot even imagine its architecture. There is a third path, however, one that is neither as tragic as collapse, nor as grand as transcendence. It is the path of the long, slow fade. Civilizations are not monolithic things. They are fragile, complex systems that require constant maintenance. Perhaps there was no single cataclysm, no grand departure. Perhaps they simply forgot. A civilization could lose its technological edge not through a bang, but through a slow, generational decay. A combination of factors, resource depletion, a subtle shift in climate, a slow-acting plague, or even a cultural loss of scientific curiosity, could lead to a gradual decline over thousands of years. They would not have been wiped out, but would have slowly regressed. Imagine their complex, global supply chains slowly breaking down. Knowledge that was once commonplace becomes the domain of a select few, and then, as generations pass, is lost entirely. Their shining cities would crumble not from war, but from neglect. Their advanced machines would fall silent, their inner workings becoming a mystery to their own descendants. They would slowly slide back into a pre-industrial state, a world of smaller, disconnected communities, living in the overgrown ruins of a past they no longer understood. They would become a people haunted by the ghosts of their own ancestors, telling myths of a golden age when their forebears could command the sky and speak across oceans. Over millennia, nature would reclaim everything. The forests would swallow their roads, the rains would dissolve their monuments, and their descendants would adapt to a simpler way of life. They would merge back into the planet's ecosystem, their advanced intelligence slowly dimming like a dying ember. In this version of their story, they did not truly vanish. Their genetic lineage may have even continued, evolving into new forms, their great minds and technological prowess becoming a dormant gene, a forgotten memory encoded in their very DNA, waiting for the right conditions to perhaps reawaken. Their end was a long, drawn-out sigh, a slow return to the soil from which they had so briefly risen. This hypothesis is particularly haunting because it suggests that intelligence is not a permanent state. It is a fire that requires constant fuel. Without the fuel of education, resources, and a stable environment, it can easily be extinguished. The Eocene anomaly in this light represents the peak of their burn, the moment their fire was at its brightest. The long silence that follows is the slow cooling of the ashes, the gradual return of darkness and quiet. They were not defeated by an external enemy or their own hubris, but by the simple, relentless force of entropy, the universal tendency of complex systems to decay into simplicity over time. Finally, let us consider a more unsettling and cyclical possibility. What if the planet itself has a role to play in this story? This is not to suggest a conscious, sentient Earth in the mystical sense, but to acknowledge that our world is a complex, self-regulating system with powerful feedback loops. The Gaian hypothesis, in its scientific form, views the biosphere and the physical components of the Earth as a tightly coupled system that maintains conditions suitable for life. What if an industrial civilization is perceived by this system as a planetary fever, a pathology that must be corrected before it destabilizes the entire organism? In this scenario, the civilization's own industrial output acted as a trigger for a planetary immune response. Their massive carbon emissions may have initiated not just gradual warming, but a cascade of geological feedback loops. Perhaps their activities destabilized vast undersea methane hydrate deposits, leading to a truly catastrophic and rapid release of greenhouse gases. Or maybe the shift in ocean temperatures and chemistry altered tectonic stresses, triggering a period of unprecedented global volcanism and earthquakes, a planetary convulsion designed to purge the infection. The Earth did not passively endure their presence. It actively, if unconsciously, fought back. The story, then, is not one of failure or success, but of a natural cycle. A species becomes intelligent. It develops technology. It begins to alter the planet on a global scale. In doing so, it crosses a threshold, triggering a powerful, corrective response from the planetary system itself. The system then violently resets, wiping the slate clean and plunging the world into a new geological era, creating the conditions for a new form of life to eventually emerge. The civilization is not an anomaly. It is a recurring and perhaps necessary phase in the planet's long life, a fever that must be burned away to ensure the long-term health of the whole. This hypothesis casts our own existence in a profoundly different light. Are we, too, just another one of these fevers? Is our industrial civilization simply the latest iteration of a cycle that has played out before and may play out again? It suggests that the ultimate great filter is not a technological or social challenge, but the planet itself. The final test for any intelligent species is to learn how to integrate itself into the planetary system as a symbiotic partner, rather than acting as a parasite. To fail this test is to be erased, your entire history compressed into a thin, dark line of waste, a warning to no one in particular. Each of these hypotheses is a ghost story, a different way of interpreting the same profound silence. The civilization could have been the victim of its own success, a classic tragedy of hubris. They could have been cosmic explorers who left their childhood home behind. They could have been the subjects of a long, slow decay, a sad story of forgotten greatness. Or they could have been a temporary fever, burned away by a planet that always, in the end, finds a way to heal itself. The truth, of course, is lost, buried under an impossible weight of time. The rock holds the chemical signature of their existence, but it is silent on the cause of their departure. This is the nature of deep history. It is a mirror in which we see only the faintest reflections. In imagining their end, we are forced to confront the possibilities of our own. Do we see ourselves in the story of a civilization that burned too brightly and too fast, ignoring the consequences until it was too late? The parallels are impossible to ignore. The carbon spike, the warming planet, the acidifying oceans. Their geological autopsy reads like a diagnosis of our current condition. Their story becomes a chilling echo, a voice calling out from across a chasm of 55 million years, asking a single, terrifying question: will you make the same choice we did? Perhaps the most important lesson is that of humility. We walk upon a world that may have hosted minds as brilliant, as creative, and as ambitious as our own. We look up at a sun that may have warmed the cities of another technological species. Our assumption of being the first and only intelligence on Earth may be the ultimate illusion, a story we tell ourselves because the alternative, that we are merely the latest in a long and perhaps tragic line of succession, is too profound to comfortably hold. Their ghost reminds us that we are not the owners of this planet, but merely its current custodians. The microscopic message of prime numbers is the ultimate expression of this humility. It is not a grand monument or a detailed history. It is the simplest, most universal signal of intelligence they could conceive of, a message in the bottle of deep time. It does not speak of their triumphs or their failures. It is a quiet mathematical statement of fact. We thought, we existed, remember that it is possible. It is a legacy stripped of all ego, a final, selfless gift to the future, a single candle lit against the immense, encroaching darkness of planetary amnesia, hoping that another mind would one day evolve to see its faint, flickering light. The scenarios for their disappearance force us to expand our understanding of what a civilization's life cycle can be. We tend to think in linear terms of progress, of growth, of a steady march towards a brighter future. But their story, whichever version we choose to believe, suggests that the path of intelligence is far more complex and uncertain. It can lead to dead ends, to new beginnings on other worlds, or to a slow, quiet return to the Earth. It reminds us that our own future is not a predetermined line, but a vast, branching tree of possibilities, with many branches leading to silence. Ultimately, we are left alone with the echoes. The ghost in the machine has shown us its face, but it will not tell us its name or its story. It has proven that we are not the first. The burden of that knowledge is now ours to carry. We are a species that has just discovered it was born in a haunted house. Every geological stratum we study, every fossil we unearth, will now be viewed through this new, unsettling lens. We will forever be searching for other whispers, other anomalies, other faint clues that might help us piece together the story of our planet's first, and perhaps greatest, lost civilization. The speculative journey into their end is not about finding a definitive answer. It is about learning to ask the right questions. It transforms our relationship with our own planet, turning it from a familiar home into a place of deep and profound mystery. The ground beneath our feet is no longer just rock and soil. It is a library of lost worlds, a graveyard of forgotten dreams. The wind no longer just carries the sounds of our own time. It whispers with the silence of 55 million years, a silence that now has a story to tell, if only we are quiet enough to listen. And in that quiet, we might begin to see our own world more clearly. The hum of our cities, the glow of our screens, the immense and intricate web of our global civilization. It all feels a little less permanent, a little more fragile. We are reminded that we, too, are writing a story in the rock. Every ton of carbon we release, every piece of plastic that finds its way to the ocean, is a word in the chapter we are leaving behind. The question is no longer whether we will leave a trace, but what kind of story future geologists, millions of years from now, will read in our own thin, dark line. Their story, in the end, becomes a mirror. The hypotheses we find most compelling, collapse, transcendence, decay, are often reflections of our own deepest hopes and fears for our own future. In trying to understand their ghost, we are ultimately trying to understand ourselves. Their silent chemical lament across the eons is not just a mystery to be solved. It is a philosophical test, a challenge to the second intelligence to arise on this world to learn from the silence of the first. The greatest tribute we could pay to their memory would be to write a different ending for ourselves. The discovery of the microscopic message does not end the mystery. It deepens it into something far more intimate, far more profound. The silence that follows the Eocene anomaly is no longer the empty silence of a world yet to awaken to the touch of a thinking mind. It is the heavy, echoing silence of a world that has gone quiet again. It is the silence of a house after its first family has moved on, leaving behind only the faintest marks on the walls and a single, cryptic note on the floor. We now walk through the rooms of our own planet, newly aware that we are not its first inhabitants, and that the quiet we once took for granted is, in fact, the sound of a long and finished story. The foundational myth of our species has been shattered. We have always seen ourselves as the singular inheritors of this world, the sole peak of Earth's evolutionary mountain. This story, a tale of lonely and exceptional genius, has been the bedrock of our philosophies, our religions, and our sense of place in the cosmos. But that story is now over. We are not the first. We are merely the next. This knowledge forces a Copernican-scale revolution in our self-perception. We are not the center of Earth's story of intelligence. We are simply the most recent chapter, a new narrative written on a page that still bears the faint, ghostly indentation of the words that were written there long, long before us. This realization reframes our most fundamental existential questions. For centuries, we have looked to the stars and asked, are we alone? It was a question aimed at the vast, cold emptiness of space. But now, a more immediate and perhaps more unsettling question has emerged, one that we must ask of the ground beneath our very feet. Are we even alone in our own history? The search for intelligence is no longer an astronomical endeavor, but a geological one. The alien we have been searching for is not from another world. It is a ghost from our own, a distant ancestor of the mind, whose legacy forces us to reconsider the very meaning of home. The Earth itself is transformed from a stage into a palimpsest, an ancient manuscript whose original text has been scraped away to make room for a new one, yet the traces of the old letters remain, visible only when held to the light in a certain way. Our civilization is the new ink, bold and clear upon the surface. But the Eocene anomaly, and the tiny message within it, is the faint underlying script. We now understand that the story of this planet is a layered text, a document of successive intelligences, each writing their chapter before being erased by the patient, indifferent hand of time, leaving only a ghost of their story behind for the next to decipher. The message itself, the sequence of prime numbers, is the most profound and melancholic part of the discovery. It is not a greeting, a warning, or a repository of lost knowledge. It is a tombstone, carved at the smallest possible scale. It is the simplest, most universal declaration of existence. We were here. We thought. We understood the universe in this fundamental way. The sheer humility of it is breathtaking. To have the capacity for a global, industrial civilization, and to choose as your only lasting monument a microscopic pattern of pure mathematics, is an act of profound self-awareness. It is a legacy stripped of all ego, a final, quiet whisper of reason against the coming storm of eternal silence. This new knowledge casts a long, chilling shadow over our own time. The hypotheses for their disappearance, especially the one of self-inflicted climate collapse, no longer feel like abstract speculations. They feel like historical precedents. The planetary fever of the PETM, once a distant geological curiosity, is now a potential ghost of our own future, reflected in our own rising carbon levels and acidifying oceans. We are walking a path that may have been walked before, following a map that leads to a thin, dark line in the rock. Their story becomes a cautionary tale, a message not in a bottle, but in the very strata of the Earth, a warning that the power to build a world is inseparable from the power to destroy it. Yet there is an alternative interpretation, a sliver of unsettling hope. If they transcended, if they left the planet behind, then their story changes from a warning to a signpost. It suggests that the destiny of a technological species may not be to remain tethered to its cradle forever. Perhaps the great filter is not a wall, but a doorway. This possibility is almost as humbling as their extinction. It implies that we are not at the apex of what is possible, but perhaps only at the beginning of a journey that ends in our departure from the familiar world of biology and rock, becoming something new, something cosmic, something that leaves behind only the faintest of chemical goodbyes. Or perhaps the truth lies in the cyclical hypothesis, the idea of a planetary immune response. This is, in many ways, the most terrifying possibility, as it removes our agency from the equation. It suggests that we are not masters of our own destiny, but merely a recurring phase in the planet's much longer life. An industrial civilization, in this view, is a kind of fever, a temporary imbalance that the Earth system itself will inevitably correct, often violently. Are we just the latest iteration of this fever? Is our entire history, our art, our science, just a symptom of a planetary condition that will, in time, be purged, leaving the world quiet and ready for the next cycle? Our relationship with the planet can never be the same. The Earth is no longer simply a repository of resources, a passive backdrop for the human drama. It is an archive, a library of lost worlds, a place of deep and layered memory. Every canyon wall is a bookshelf, every river delta a collection of forgotten stories. This knowledge instills a new sense of reverence, a feeling of walking on hallowed ground. We are not the owners of this planet. We are its curators, its librarians, and we have just discovered a book written in a language we are only beginning to understand, a book that tells the story of the tenants who came before us. This discovery will ignite a revolution in every field of science. Geologists will no longer just be reading the history of rock, but searching for the grammar of a lost technology. Paleontologists will sift through the fossil record, not just for new species, but for the subtle, inexplicable ripples of a civilization's ecological impact. Geneticists may even look for a ghost in the code of life itself, searching for signs of ancient, sophisticated genetic manipulation, a legacy hidden not in stone, but in the very DNA of the organisms with which we share the world. Every branch of science becomes a form of deep-time archaeology, searching for other whispers from our planet's first children. We must now confront the Fermi paradox from a new, terrestrial perspective. Perhaps the great silence of the cosmos is not empty, but is filled with the ghosts of civilizations like this one. Perhaps intelligence is not rare, but it is tragically fleeting, a brief candle that illuminates a single world for a geological moment before being extinguished by its own success or the natural cycles of its home. The universe might be a graveyard of these brief, shining moments, with the silence between the stars being the cumulative sound of countless forgotten stories. Our planet's own history may be the ultimate proof that the universe can be full of life, and yet remain profoundly, terribly quiet. And so, we are forced to look at our own works, at the world we are building, and see it through the eyes of deep time. The hum of our cities, the plastic in our oceans, the carbon in our air, it is all part of the thin, dark line we are currently creating. We are, at this very moment, composing our own geological epitaph. The knowledge of our predecessors gives us a unique and heavy burden. We are the first species on Earth to know that it is possible to fail, that it is possible to vanish so completely that only a chemical stain remains. What will our layer in the rock say about us? Will it tell a story of a species that learned from the silence, or one that was doomed to repeat it? The choice, for the first time, is ours. We are the inheritors of a profound and silent lesson. We are the second mind of the Earth, and we have the incredible, terrifying privilege of being aware of the first. Their ghost does not offer us answers or guidance. It offers us only a single, stark fact. We are not special. Our intelligence does not grant us a permanent lease on this planet. It only gives us the capacity to understand our own fragility, to see our own potential end written in the history of the world itself. We can no longer plead ignorance. The silence has been broken, and we have heard its story. This knowledge does not have to be a source of despair. It can be a source of profound connection, a sense of kinship across an ocean of 55 million years. We are not alone, after all. We are part of a lineage, a tradition of intelligence on this world. Their story, however it ended, is now part of our story. In their silent, microscopic message, they reached across the eons to say, "You are not the first." It is now our responsibility to live in such a way that a future intelligence, millions of years from now, might find our own trace and know that we were not the last. The narrative of humanity is no longer a monologue, it is a dialogue with a ghost. We now live in a haunted world, but perhaps that is what we always needed. To be haunted is to be reminded that the past is real, and that our present actions will echo into a future we cannot imagine. The hum of our cities now sounds different, less like a song of triumph, and more like a quiet echo of a melody the world has heard before. We are left in the quiet, in the shadow of their immense and unknown story, holding the new and fragile understanding that we are but a brief, flickering light in the long, deep, and mysterious life of our planet. We began with a simple question, a whisper against the background noise of our modern world. What if the hum of our cities is not the first song of industry this planet has ever heard? We searched for a ghost in the geological machine, a faint possibility hidden in the deep silence of the past. Now, the silence has answered. We know that another mind was here, another hand shaped its world, another consciousness looked up at this same sun and contemplated its place in the universe. But this answer has not brought clarity. It has shattered it. The discovery of their microscopic farewell note does not close the book on their story. It reveals that we have been reading a single, lonely chapter in a library of forgotten worlds, and the rest of the volumes are missing, turned to dust by the patient, relentless turning of the ages. This knowledge transforms the very ground beneath our feet. The earth is no longer simply our home. It is a haunted house, and we have just found the first undeniable proof of those who lived and died here long before our own story began. We are not the sole inheritors of this world's intelligence, but the second, and perhaps not the last. Every layer of rock is now a page from a history we never knew existed. Every fossil is a potential footnote to their story. This realization forces upon us a profound and unsettling humility. We are not the central protagonists of this planet's long narrative. We are simply its most recent authors, writing our chapter on a palimpsest, the faint, ghostly indentations of a previous epic tale still visible beneath our own fresh ink. In the quiet contemplation of their fate, we find a mirror. The story of what became of them is a reflection of our own deepest fears and most transcendent hopes. Do we see in their chemical scar the tragic echo of our own industrial age, a civilization that burned too brightly and paid the ultimate price? If so, their silence is a chilling, cautionary tale, a warning whispered across 55 million years. Or do we imagine them as cosmic graduates, a species that solved the great puzzles of existence and departed for shores we cannot even conceive of? In that case, their silence is one of aspiration, a signpost pointing towards a destiny beyond the confines of a single world. Their unknown end has become a Rorschach test for our own. Their final message, that delicate microscopic sequence of prime numbers, is perhaps the most profound legacy of all. It is not a history of their triumphs, a warning of their failures, or a map to their lost knowledge. It is something far more elemental. It is a tombstone carved from pure reason, a quiet, mathematical declaration that says nothing more than, "We were, we thought, we understood." It is an act of incredible humility, a final, selfless candle lit against the encroaching darkness of planetary amnesia. They chose not to be remembered for their power or their art, but for the simple, elegant fact of their consciousness, a thread of shared understanding that connects us to them across an impossible ocean of time. And so we are left in the quiet, holding this new and heavy truth. The hum of our cities now sounds different, less a song of singular achievement, and more like a familiar melody the world has heard before. We are a species that has learned it is not the first, and with that knowledge comes a profound responsibility. We, too, are writing our story into the rock, leaving behind a thin, dark line for the future to find. Their silent lament has given us the one thing they may have lacked, a precedent. The question that remains, the one that will now echo through our own civilization, is no longer whether we are alone, but whether we, the second mind of Earth, will learn from the silence of the first.